Hey, welcome to this video on Rust conditional statements. My name is Doug Melford from Lambda Valley. Let's get started. All programming languages that I know of have conditional statements like the if statement, and Rust is no different. But Rust has a few extra bells and whistles that others may not. Let's address the most basic conditional statement that Rust has, which is the if statement. I'm going to create a simple boolean so that I can use a variable within my if statement. It begins with the if keyword, checks the condition for true or false, and the body held in the brackets. I'll go ahead and print something just so it's actually doing something. The double equal sign is a comparison and is very similar to other languages. The starting curly bracket should be on the same line as the if condition. The if statement needs a Boolean result for the condition. Often you're comparing two pieces of data to see about some equality. Since my variable is already a Boolean, though, I can shorthand it like this. Use whatever you like in this case. Rust doesn't weigh in with its own preference. I'll set mine back to include the equal sign for now. Many other languages have parentheses to surround the condition. Rust does not, or at least it's not necessary. It'll show you a warning saying the parentheses in this case are not necessary. Sometimes you want the opposite value of a Boolean. For example, you want to check if something is false. Rust supports exclamation points as a not operator on a Boolean. This would be equivalent to checking if it's false. It's just a different way. Note that the warning for the parentheses went away because now they're useful for something. Or even shorter. All are equivalent logic. It's up to you what to use. Let me clean up some of this to simplify for our next example. Okay, so you can also include an else statement. The else keyword should be in between the end of the previous branch and the start of its own branch. If you didn't format it exactly that way and put the else on its own line, it's not a big deal and Rust will compile, but I recommend you stick with the Rust convention. It makes it easier for others to read if it's always formatted the same exact way across developers. I have my Visual Studio Code settings such that the code auto-formats when I press Save or Control S, which I'll do right now. If you see my code jump slightly in my videos, that's what's going on. Usually it's pretty handy. Sometimes it's annoying if you really want to format something your own way. You can change your settings for auto format in Visual Studio Code if you don't like that. If you follow my setup, your settings should already format on save as well. You don't need to have a single explicit variable. You can do more complex expressions. If I create a couple more variables to hold some integers, I can include that into something more complex. As long as the expression returns a Boolean, it'll work, which is what those comparisons are for. It's not limited to numeric or Boolean comparisons either. String comparisons or other data type comparisons will work too. The two vertical bars represent OR logic, meaning if A is true or B is true. The two ampersands represent AND logic, meaning if A is true and B is true. So this reads some bool is true or some int is greater than 100 and some int 2 is equal to 200. Although Rust often doesn't need parentheses, in more complex conditional logic such as this, you may need parentheses to be clear for us silly humans to understand. If I group the pieces like this, that's logically different than if I group it like this. The parentheses make all the difference. Without the parentheses clarifying the logic, the statement could have been interpreted two different ways by a developer reading your code. Rust would have had only one way to interpret it, so it won't get confused. But you also have to be mindful of other developers. Without the parentheses, it could have caused confusion about your intention. Note that we don't get that warning about unnecessary parentheses because in this case, the parentheses actually clarify your intention. The Rust compiler understands that in this situation, it's actually helpful. If all you have are OR statements, or if all you have are AND statements, you're fine without any parentheses. It's when you mix and match and or statements that people can get confused reading the condition. Do your team a favor and just be clear. You can also chain together if statements with an else if. Rust will check each branch condition in the order that it sees it and hit one and only one branch. Once it finds the correct condition, it doesn't bother checking the other branches. If no conditions are met and you don't have an else statement, no branches will be hit. You can use all the else ifs you need to fully cover your needs. There's no practical limit. Be aware that if you have an else branch to catch all other situations, that will need to be at the very bottom. Often other languages have a way to do inline if statements to return a value. In Rust, you pretty much use the same syntax that we've been using, except that it's inlined. If the formatter sees that you're doing an inline and it can fit it all in one line, it will. When we're populating a variable this way, you'll need a semicolon at the end of the entire if statement. But since we're using the if statement to fill a variable, you don't put a semicolon after each branch return statement. It's similar to a mini function where no semicolons indicate you're returning a value. When populating a variable from an if statement, your if statement isn't limited to an if-else. It can be just as complex as the other branching logic version that we did previously. I can put an if-else on here just fine. If I now press Ctrl S to save it, you'll see the auto formatter recognizes it's probably too big for a one-liner, so it spreads it across multiple lines to make it easier to read. And now it may seem a little more clear where the semicolons go and where they don't. As mentioned, since we're populating a variable, we'll need a semicolon at the end of the entire statement. But since each branch is returning back a value to populate the variable with, no semicolon is used. Just like a function, no semicolon indicates you're returning a value. In this case, we're just returning it to a variable. Again, it acts like a little mini function. You're allowed to write other code within each branch if you like. As long as it returns an integer or whatever value you're expecting before it leaves the branch, it's cool. Even if each branch returns data, but it returns a different type, that won't compile either. Here, if I return a float denoted by a dot at the end of the number, the compiler will complain because some branches return an integer while others return a float. When you get compile errors, keep in mind that Rust may not always identify the exact line that's causing the problem. The important part is able to understand what the error is saying, and in this case, it's saying you have incompatible types, and know why that's an issue. Rust simply can't know if the float is the correct type or the integer is the correct type, so there's no perfect way to flag the issue. The compiler is a wonderful tool, but it can't read your mind. The next conditional statement I want to discuss is match. It's very similar to the if statement in many ways, but will have more capabilities that the if statement won't. With the match, you put what you're trying to match up top and then have branches for each possible value. Your first reaction might be, so what? But wait, there's more. It's not just a binary comparison. You can do more interesting things. I'll create a match that takes a number as its input and then make multiple branches for possible conditions. If you only have a single line of code for each branch, you can omit the curly brackets and just end it with a comma. It's shorthand and can tighten up the verboseness of your code. This is saying if sumInt is 0, perform one branch. Else, if sumInt is between 1 and 100, do that branch. Otherwise, go to the else branch, which is represented by an underscore. The match statement will do an exhaustive check, meaning it'll make sure all possibilities are accounted for. This is very helpful when using it in enumerations, which we'll touch upon in a future video. If you're planning on having multiple lines for a branch, you'll need to surround the branch with some curly braces. Note that a comma can go away then, but if it's left there, it'll still compile just fine. Just like we did with the if statement, we can assign variables based on the return result. It will have the same strictness as the if statement where it'll check each branch returns the same data type. If I change one of these to float, we'll get a compile error. Just because I'm returning data does not diminish the match statement's capabilities at all. I'm just going to quickly create a second variable filled by a match statement that has multiple branches. One thing I want to note is that you can do an OR statement with a vertical pipe. If sumInt is 1 or 2, it'll use this branch. Unfortunately, with the if statement, the OR was represented by 2 vertical pipes. With a match, it's only 1. If you mess up, it's no big deal. The compiler will catch it and tell you how to fix it. This is really only an introduction to the if and match statement, and it's really got a lot more goodies up its sleeve. In a later video, I'll be talking about enums or enumerations, which will take this match discussion up a notch. When we do rich pattern matching, we'll really open up the throttle. Match gives you a lot more power at your fingertips. Stay tuned, some good stuff is coming. I want to briefly mention that there's also something called an if-let statement. It is another conditional statement, and it's really shorthand for a specific type of match statement that we haven't covered yet. But don't forget that name. If-let is coming. Thank you for watching this video. Once again, my name is Doug Milford from Lambda Valley, and I'll see you next time.